The final topic is variation of parameter. I said section 6 was not that important, save for two formulas and their proofs. But this one, variation of parameter, I have to say they are important. How feasible they are, I'm not so sure because the computation is likely to be really horrendous here. Oh, why are they all open? Excuse me. Okay, I'm ready. Okay, first example of variation of parameter is finding a second solution. If you know one solution of homogeneous equation, and if you're looking for another solution which is linearly independent from the other, then you can use a sort of variation of parameter by doing something like this. U of t times the first solution you already know. And this U of t will become, well, this U of t is a parameter that you'll have to adjust and find out. How do you work out? Well, okay, here's an example. We have this differential equation, and then y1 is e to the t power, and then we are looking for y2. Put it over here, y2 is u of t times exponential, and then go from there. Basically it's this, y2, excuse me, 2 of t is equal to u of t times exponential of t, oops, based upon this formula here. And what do? You take the derivative, and then you take the second derivatives as well. And find out these two using appropriate product rule and so on. And then plug it in, and you're looking for u of t. That's the kind of computation you'll have to do. Okay, let's see. Let's set up the derivative. y2 is u times y1, okay, but I think I'm gonna need bigger font for this. And take the derivative using the product rule. So far so good. Second derivative, more product rule, and as you can see, it's an elementary computation but tedious and horrendous. Luckily, you don't have to do it another time for the third derivative. That's about it. Alright, let's put those into the original equation. Here we go, t minus 1, and then we put this one in there. And t, y prime, so we put this one in there. And then finally y, that's y2, so we put this one. And then let's work out. But then again, do you see exponentials are common everywhere? So we can take all the exponentials out, and that's what this one is. U double prime plus u prime plus u after taking all the exponentials out. From here, u prime plus u, taking all the exponentials out. And this exponential out, you get just u. And what do you get? Break up all the parentheses, and then rearrange, we get this equation. T minus 1 u double prime plus t minus 2 u prime is equal to 0. Okay, we started off with this equation. After all this process, we ended up with this equation. Is it better? Hey, this too is second order. And then variable coefficient. Was there any improvement at all? As a matter of fact, look closely. This is not second order. This is a first order. U double prime, U prime, but no U. So you can start from here as the original function. And then this is a first derivative of U prime. And then you can work it out using the integrating factor method. I'm really tempted to stop here, but let's go on. So, okay, let's work out. P is, let's see, let's take one more. Okay, that thing is, so U double prime plus T minus 2 over T minus 1 is equal to 0. So this is a standard form, and this is P, that's F. So to find out the integrating factor, start from here, and then we have to find out the antiderivative of this. So to take antiderivative of that, let's see, that's a partial fraction, and the antiderivative is t minus log of t minus 1. So we get the integrating factor like this, e to the q power. Can you simplify that? Yes, you can. T power minus, so over this e to the log t minus 1, and exponential log cancel out, we get e to the t power over t minus 1. That is the integrating factor. So okay, that integrating factor times u prime is equal to 0. Right hand side is 0, you see. So integrating, what do you get? This integrating factor times u prime is equal to c. And remember here, you're not trying to solve the equation here. You're just looking for just one u value. That's it. One u value, so that u times y1 is another solution. So all you have to do is find out something simple. Instead of c, which is arbitrary, just keep it as simple. Keep it as 1. 0 is bad idea, but 1, that's okay. All right. Okay, if you put 0, that's going to be a bad idea, because if you're looking for u prime and flip over this, multiply all this, and then you have 0 times something, you lose the information. As long as this is not 0, it'll work out. Let's keep it as 1. Flip this one over to the other side. What do you get? T minus 1 times e to the negative t power times 1, and that's your u prime. How to get u? Well, let's take the antiderivative using integration by parts. If you do that, you're going to get negative t e to the negative t power. And integral constant plus c pops out. And of course, as I said earlier, you're not really looking to get a full solution here. You just need one u value so that you can find y2. So let's keep it simple. What kind of c value is sufficient? This time I'll select plus 0. There's no multiplication here, so plus 0 will not lose any information. So u of t is therefore negative t times e to the negative t power. And therefore, finally, y2 is u times exponential. We get negative t power. So y1 is e to the t power. Y2 is negative t power. So the general solution will be constant times first, and then some constant times negative t. But, there are too many negative signs. So we could always select negative number here. So you can change this negative into plus, no problem there. But if you keep it as minus, that's going to be okay. You're going to earn full credit anyway. So that's how you can find out your solution. And this kind of general method is an example of variation of parameter. But often it's called the reduction of order. That's another name for it. But It's an example of variation of parameter. I mean, something times this coefficient part, and that's a parameter that we have to identify. Let's see, I don't think I can do all these in a single video, so let's take just a little bit more time reviewing this. So let's begin with an equation here. One solution is given there, and you're looking for the second solution. How do we do that? Variation of parameter. U of t times the previous solution, and you're looking for this u. How do you do that? Brute force computation, the derivatives, first and second derivative. We need both because this one goes all the way up to second derivative here. If the original equation had been the third derivative problem, we'll have to do this one more time, heaven forbid, but luckily we don't have to do this third time. Okay, alright. And put all this into the original equation and simplify. Here we go. Maybe I shouldn't have closed those. Yeah, okay, alright. Here we go. Y double prime, that goes here in place of this. Y prime, that goes here in place of this. And then this is just original function, u times exponential. From here, all exponentials are common, so they all cancel out. And what's left will be this equation. Simplify, further simplify. What do you get? You get a second order linear equation, but it's not real second order. It's actually a first order. First order equation of u prime. You can do it through integrating factor. As for the integrating factor, I'm really tempted to stop here and then use integrating factor to complete the problem. But if I gave an overview, it's kind of like this. And find out integrating factor. Start from the standard form, and then p, and then its antiderivative q, and exponential q, and simplify that. That's your integrating factor. So integrating factor times u prime, that derivative is right inside, which is 0. Good. Antiderivative of 0, we can have arbitrary constant. And then don't keep it 0 because you'll have to multiply later. So anything other than 0 will do. 1 is greatest. Multiply it out, then 1 times this one. And then this is u prime, so you have to find out u. So take the integral again. Turns out this is gonna be this function. If you use integration by parts to calculate it, we have plus c, and then if you use plus 1 here or minus 1 here, perfectly fine. I'm not gonna argue with that, but it is possible to get 0. You couldn't get 0 here because you had to do multiplication, but here it's okay. But to be safe, if you do it just 1 here, I think that's fine. That's totally fine. And how about this? Let's see. I put 1 here, plus 1 here, so that will be plus 1 times e to the t power. And this is not negative t. Instead, now negative t plus exponential of t power. That is your second solution. So your general solution is c1 exponential plus c2, and then we have negative t plus e to the t power. But then again, we have this exponential, another exponential, so we can put together as another coefficient. So a1 and exponential, and then plus a2. Because we need the t part. And that's going to be another solution here. If you stop here, you will earn full credit, so that's fine too.